Well, hi, good morning, and thank you for joining me in my shop. Today is October 18th, and I'm starting on this really neat looking little radio, just an AM radio, made by a company called Bendix. You can see it right there, Bendix Aviation Corporation. Aviation Corporation. Now, there's a lot of Bendix radios that look kind of similar in that this part of them is the same thing. It's this curved piece of plastic, and unfortunately, a lot of these radios, this gives up the ghost. This thing can shrink, twist into an ugly shape. This one here, unfortunately, the paint is coming off the back of it. You can kind of see. Sorry about the lighting here. Let me tip this a little bit. You can kind of see some of the white paint has disappeared behind the numbers in that. Too bad. But that sends a loud message to me. Don't touch that. I learned a hard lesson many radios ago, where on most of these radios, the print is on the back of the material here. Not all of them. Some of them have print right on the front of the glass. This is plastic, this one here. I cleaned the front of this radio just fine, and then I tested the back very carefully because I know the paint can come off. I tested it really carefully. It looked okay. I went like this. Then I used different kinds of paint, and I just swiped off a whole bunch off the back of the dial face, and almost ruined it. Ruined it in one sense, but wow, that really put a message to me about these radios. You do a lot of work on them to make them operate and all that kind of stuff, and then ruin this. This is what people see. People look at this. They look at this. They look at these knobs too. And looking at this case, look at this thing. This is kind of interesting how it's shaped. It looks like three lumpy pieces put together to me. I see one coming around this way, and I see one coming over the top like this. And then I kind of see a thing in the middle, this piece here, kind of in the middle. Interesting shape. It's all one piece, but you see how they've used sharp edges here and here to make it look like it's a number of different pieces put together. This, of course, this is Bakelite, of course. Okay, what do we got on the back here? We've got a great big handhold. Wow. That's a little bit unusual. Mostly, I'm against picking these things up any other way than down under here. Some radios have a handle on the top, the handle rips off, radio's going down, or others, when you lift them, you are stressing a fragile plastic cabinet. This is not plastic, but a plastic one, you can crack it or increase a crack, or who knows. I think it's better to pick them up. This way too, you can get under the base, and you'll really be carrying the weight of the radio, not holding it this way. So they've even shaped the back, though. It does have a bit of a pattern to it. And this is a scratch, not a crack. Bakelite has turned out to be a really long-term material. I think this looks, the surface of it may not look the way it did when it was new, but other than that, no warps, no cracks. Bakelite, yeah, replaced by plastic, by oil-based plastic. So this radio is owned by a fairly serious collector, somebody who's got an eye and spots nice-looking radios like this. She has not tried this. She has not plugged it in to see what it does. My job is to find out the condition, the electronic condition of this radio, which may be perfect. It may be absolutely fine. Or it may be in line for a restoration. So plugging it in is a good idea. So this looks very new to me. You look underneath, you can see a fairly good attempt at putting these wires on. You wrap them around the pin, which is the way you do it. You come up through the middle, around the pin, and around the screw. And unfortunately, though, there's quite a few loose strands in here, and they will eventually, or they can eventually, work their way right to the outside edge here. So when you grab this, yee-haw! fun ensues. And this is clearly new. This is clearly a new chord. This suggests somebody has worked on this radio. Obviously, at least to put a chord in. I don't like turning these on totally blind, so we're going to take the radio out of its cabinet. And this one looks like the cabinet goes up. How can it go up? It's got these sticking out, doesn't it? So these have long collars here that go back into the radio. One of the reasons for that is, so when you pull the knob off, the plastic knob off, the metal knob remains inside the cabinet. You can't touch it. Well, you can. You stick your finger in like that. That's because these 5-tube radios have a little bit of a danger to them. Now look again at the plug. Is there any polarization in that? No. This is not a polarized plug. This is the prongs aren't actually lining up 100%. Yet they're riveted down solid. So that won't matter. Just another observation. So we're going to put this guy on its side here. Oh, surprise! We get a layout diagram. This is basically showing where the tubes are and what they are. But here somebody's written Sam's 41. It probably means, I'm sure it means Sam's Photofax for schematics, probably page 41. But I don't know. But what the 41 means. This is something sort of embossed or stamped into this metal bottom. You can see that there's words there. I'll read it. Remove red screws to replace tubes. Remove red screws to replace tubes. Okay. Well, I don't see any red screws anywhere. You can see the antenna here. It's been glued onto the back of the radio, but unlike other radios, when the chassis comes out, that's not coming out with it. So they have the wires, they're soldered right in here. So it looks like you've got to desolder these two wires to take this radio out, although they're fairly long. Well, once they're desoldered, you can't operate the radio, so let's leave them soldered. There's a stamp here, can't read the rest of it. And any special notice, license notice, this apparatus uses inventions of United States patents, licensed by Radio Corporation of America. Patent number supplied on request. There's something else here, but it's scratched off, something similar. 25 watts. Any defect in said receiver should be brought to the attention of the from whom it was purchased, who will be authorized to furnish a something or other for repairs or replacement. That's a little late for that. So we got to take some screws out here. So these screws hold this plate to the chassis. These screws hold the plate onto the radio cabinet. That means you could take, well, if you take these screws out, the radio's just going to fall into the cabinet. Okay, I think it's kind of obvious what has to happen here. I'm going to take these 4 corner screws out. Now these screws probably go right into the bakelite material, and surprisingly enough, these will be machine screws. Surprising to me. So it's a machine screw. You can tell by the threads, right? And it's going straight into the I want to call this plastic. I don't think you can call this plastic. bakelite is a resin material, molded resin, with some kind of filler, usually sawdust, I think. Which is why if you disturb the surface on this one's very good. If you wash it too hard, scrub it something, put something abrasive on it, you'll start revealing the filler. It'll start getting like a mottled look as the filler becomes visible, because you literally sanded the surface off. So I think the best thing to do with these radios is little as possible when it comes to the cabinet. And it could be maybe special ways of cleaning this stuff. And I've certainly read a few, but what I do is just very gentle washing. There, put the knobs in there. The radio's flopping around here. You get a good grip of it. Take it out and keep the tugging on those wires. Okay, here we are. Can we just stick it on its edge here? Not really, no. Really can't do that. Shouldn't really put it upside down. How can you lay this guy down? Apparently I have to keep going here, because I can't put it down. So we're either going to see one of two things under here, right? Well, not necessarily one of two, but nobody's done anything. All the capacitors have been changed. Does anybody want to take a guess? Or one or two capacitors have been changed very purposefully. Those are the three possibilities. With the new power cord there, the look of this radio, I'm going to guess it's completely done. All the wax capacitors are gone. Okay. Now we're about to find out. Da-da-da! I was right. I was right. Looks like a lovely job done. Looks like a nice job done by somebody. So I'm looking to see if there's nothing, this, filter capacitor here, that's also been replaced. Lovely. Okay, we can operate this guy. I'll set him like this. Try not to break those antenna wires. Okay, but first it's coffee break time for me. Then when I come back, we're going to turn this guy on and see what he does. Having said what I said about this, I couldn't carry on without fixing it. So I've applied solder here, so these wires are held together. I'm going to shorten these. This is a little too long anyway. I'm going to get rid of this tip here. Unsoldered wires right at the end. Okay, put that back in. Screwdriver, please. There's a right way and a wrong way to put wires under a screw. The way I'm doing it is the right way. So when you tighten down the screw, it pulls the wire further under. If you do it the other way, it pushes the wire out. I think most people probably know this. Most people watching my video like you would probably know this. But I don't know. Do you know it? I need something to talk about while I do this. So there we are. That's one. So there's no chance now of strands coming out. Which is what I wanted to make sure of. Since I don't think I'm going to be doing any work on this radio, I think I better video stuff like this. What I will do is I will check the radio's alignment, that's for sure. You know, it's possible somebody who did this work, like do work on the radio, all you really need is a soldering iron to do that. Maybe he wasn't able to align it. There we are. Okay, you could be critical of that too, but it's better off. It's better than it was. I think I'm gonna run the cord. Plug out one thing here. So I'm plugging it into my power source. If this is the first video of mine you've watched, this power source doesn't go right to the wall. It goes through a number of things. There's an isolation transformer and another isolation transformer. That's this one. This one's a variable transformer. I can set the output level. But most importantly, when I first start up something like this, I run the power through these light bulbs. And the reason for that is to restrict the amount of power that can be delivered. Because initially you don't know. There could be a short circuit in here. How do you know? You don't know. And if it's something like a transformer, you want to find that out right away. And dim bulbs help with that whole process. One more screw. Yeah. So when I power this up, I'm going to have this light in the circuit here. This light here. This light here in the circuit. The other light is unscrewed here, so it's not part of the deal. Electricity will go through the light over to the radio, go through this device on the way there. We'll be able to read the voltage right at the plug here. And a radio like this can work with as low as 90 volts or so. So we'll kind of start in that range and see what happens. And okay, so here we go. Here's what you should expect the light to do. Come on bright briefly. Go down and then come back up. That's what you can expect. Here we go. Oh, first practice session. That's the on off. Sounds good. Sometimes you can tell just from the sound of these switches if they're not going to work, and the tuning is good. And we'll go down to the low end here. Oh yes, now tuning. What am I going to tune in my shop here? So this radio on its own with its own antenna, probably not going to do well in my shop. But what I have is I have a good outdoor antenna. It's a mini whip antenna. It's an amplified antenna, and the signal comes into my shop here. And you can see I've got a cord plugged in, and that cord runs over to this loop. It's just 3 turns of wire hanging here in space somewhere near the radio. That can help. We can put this right up against this antenna if it really needs help. Otherwise, this guy's, now we can try it. We're not likely to pick anything up even if it's working well down here. Also, I have the antenna laying flat, which doesn't help. So first test, switch is off, nothing should happen. Okay. And we're going to be, the maximum we can supply is 107 volts right now. But with the dim bulb in the circuit, it won't be 107, but it won't be much less. What do we see? This thing draws 35 watts. That's not very much. Okay, so it's turned on. I'm going to turn the volume up a little bit. There we go. Watching the bulbs. Bright. Bright. Going dull. Going down. Going down. Going down. As it goes down, this voltage goes up. It's only 44. 49. 51. It's very low. That's very low. That's very low. One bulb in. 63. The radio won't operate with 63 volts. So what we can do to jump it up is I'm going to screw in this other light bulb here. These two are just in parallel, and so there'll be another current path, and much more current will get here. I can see the tubes are lighting up. Where are we at? 68. It can't possibly work, can it? We don't hear a thing. Okay, here we go. But at the same time, my furnace fan is coming on, so you might hear that in the background. So this will jack the voltage up quite a bit, maybe up rate. It's 101 volts, so the radio should operate now. Dirt and the volume control. Let me put a knob on that. Let's see if it makes the same sound when I turn it. You notice it doesn't make a sound now? If I touch the knob though. So the knob is it's a metal knob going through a metal bushing in here, and it's just making on-off contact with the chassis, and with my hand on it. That's what's happening. Now normally this wouldn't happen because you can't touch the chassis on a radio like this, and this radio is actually, well, we have to look at the schematic to be sure, but to some degree it's got a danger about it, a chassis voltage danger. In my shop, because it's plugged into an isolation transformer, I cannot get a shock to earth from this, which makes it a little more safe. But because out of the cabinet and the chassis is right here. Okay, seems to be very consistent. Let's see if we can tune something in. So we're not getting any stations, but I'm going to move that antenna loop much closer. Any noises? I think there's a station right there. Maybe not. That's 860, French station. That's Hamilton. I think that's Hamilton. 1150, I think.
Woodside area this morning after battling a significant house fire that spread to neighboring homes.
680's Kevin Meisner is on Kip and Davy Avenue with the latest from the scene.
This was a deep-seated, stubborn on the roof of the 2.5-story home using a chainsaw to pull apart smoldering hotspots. This fire broke out around 3:30 this morning and spread quickly. Jack lives 2 doors down.
When I went outside, there's
Doing a little better at the low end, but then this is where the local, more powerful stations are, and nothing really local to where I live, but at this end is there's a few community stations. There's one at 1430. Maybe we can try that. the end.
Ça fait tellement innovant de livres en réalité augmentée.
A lot of noise coming from that too. Let's see if we can get the station out at all. I don't think so. Sounds like it's picking up radiation. Okay, I think what we need to do is just run through some basic checks of the alignment of this radio. Ooh, it seems to have one IF can. That's a little weird, don't you think? Shouldn't there? There's one IF can. Where's the other one? Underneath, maybe? I don't know. Only one IF? Is that possible? I guess it's possible. That would not be common. Okay, power off. Where's the other IF? Unfortunately, you can't set this radio on its side, really. So there's a coil here. There's a coil here. They're not adjustable. One IF? I think maybe we better take a look at the schematic for this radio and just see one of the IFs has fallen off the radio and it's gone. Just kidding, of course. Okay, we're going to do that. Okay, so I found some information on the radio. Here's a page here. This has all come from Radio Museum. That's a site that's collected this information. There's a picture of the radio, and here's instructions and alignment instructions here. This is from Sam's. Okay, and I've got another piece here. Shows the schematic, and there's the radio there. Walnut finish plastic. Interesting, they call it plastic. Sure looks like Bakelite to me. It's got the Bakelite pattern in it. It must be Bakelite, but is Bakelite plastic? I don't think it qualifies exactly. So, an interesting question is, what about this one IF? Well, there's two of them on the diagram here. Two right here. Let's look at the alignment instructions. The alignment instructions are aligning the IF maximum to the rear. Well, there's four things to adjust, so there's two IFs in here. Okay, here's a diagram of the top of the radio. So here's the one IF can I can spot. C3 and C3A, C3B. The other one is 6CA and B. Well, here they are, right here. There's no can there. Well, that's a hole in the chassis with screws you can slip a screwdriver down into. Well, that's the top of the IF, located underneath the chassis. Well, I'm looking at it. We'll have to have another look underneath, but it's a little bit of an unusual way of doing things. Quite unusual. Okay, but there we are. So that's the IF adjustment we're planning on doing next. 455 is the frequency. This is apply through, which is to use a dummy, I don't want to say dummy antenna, a method of modifying the radio's view of what it's connected to. It's connected to the signal generator, and if I'm not careful, the signal generator looks like a short circuit to the radio, and that may confound some of the tuned circuits. So you want to make it look like nothing. 0.01. That's what I have in there, coincidentally. 0.01. I happen to pick on. Okay, I think we're ready to go. I'm going to leave this. Yeah, I think we're ready to go here. Okay, down at the bottom here is some stuff to read. General, before making any alignment adjustments, turn the receiver and all power operated test equipment on and allow it to warm up if at all possible for at least 5 minutes. If at all possible. How could it not be possible? 5 minutes. A lot of them say 15 minutes, half an hour here. Turn tuning gang fully closed. Set dial pointer directly over reference mark on dial. Reference mark on dial. Okay, so I see these. Okay, I see where these marks are. Look at how wide this thing is. What kind of precision marking is this? It's actually like that on the radio. Okay. After receiver is warmed up and dial pointer's been properly set, turn volume control full on. You know, I seldom do this for obvious reasons. And rotate tuning gang to full open. Turn tuning gang fully closed. Set dial pointer directly over reference mark. Oh, this mark. I didn't see this one. Is this one there? This one is there. Well, I don't see that mark. Where is it supposed to be? Right on the edge of this piece. Okay, that... I don't see it. I don't see this mark. I see this one. And this is the cutout for the speaker to sit in, and the speaker flange is covering this area here. You can't see this corner. Oh, we'll worry about when we have to. Chances are the pointer's already set anyway, and we'll find that out right away. Connect low range output across voice coil. So, and refer to alignment chart. Signal generator to be connected to external antenna connection through isolating capacitors given an alignment chart. Keep input signal as low as possible. Precautions. Isolating transformer should be used between AC power line and receiver for protection of any test equipment. Yes, you can damage your test equipment with these 5-tube radios if you're not careful. There's the table. If calibration does not check within the frequency, both oscillator and antenna sections, if calibration does not check within the frequency, but am I reading this wrong? Does not check within the frequency, both oscillator and antenna sections of the gang C condenser must be bent. Oh boy, that's the first time I've ever seen instructions on bending the plates in a capacitor. That's probably not going to be the case. So signal generator connected to external diameter complete alignment. Oh, you're not repeating yourself? Okay, stringing diagram. Good thing we don't need to pay attention to that. Okay, we're ready. Let's turn on the radio and we'll fool around for 5 minutes. Well, maybe not even 5 minutes. Okay, right. I don't have to do anything. Camera's on already, Jim. Okay, we better get this guy operating. Okay, we'll start him up with the dim bulbs, but I'll switch to full power once he's operating. You can see I've got the signal generator set to 455. There. Hello, radio. Wow, slow one to warm up. Very slow to warm. Oh, that's because I've got the dim bulbs in. Okay, everything's fine. We're going to give it the full voltage here. What is it? It's 106. It's just a wee bit low. I'll just turn it up a little bit. It's still a little low. It shouldn't make any difference at all, but why not? Okay, so we're 111. There we go. Now, I'm going to, volume full. No, I don't think so. So I'm going to connect the signal generator up. Probably the radio will go quiet, or it may start howling the 1000 hertz here. That's not a good sign. That's not a good sign at all. So that rumbling indicates some kind of grounding mistake here. getting worse and worse here as I do this. Wow, isn't that interesting? So I clipped it to the capacitor frame. I clipped the ground to the capacitor frame, thinking the capacitor frame is grounded, but in a lot of these radios it's not. The capacitor frame's actually on grommets and is isolated. And that's probably the case with this one, because I can see just a little bit of an air gap under it. So using the frame as a ground was a no-no. Okay, so we're on the chassis now. Everything seems to be working okay. We're hearing the tone, which is good. The radio can be tuned anywhere during this, really. Doesn't really matter. So I'm going to vary the frequency of the signal generator, find out where the peak is, and if it comes out at 455, I think we're done already. And that'll tell us that the last guy did an alignment. So here we go. So it's a little off. It's up at 458. Now, once in a while, a person may alter the IF frequency from its standard, in this case 455. They may move it up or down to affect the position of the dial pointer. Not something I do, but I guess it's a way out of a problem. If you can't get something somewhere, you can start moving the IF frequency around a bit. So that's probably not the case here. What's happened here is almost certainly it's just not aligned 100%. So we can do it. We can do the alignment. Now, one alignment adjustment is done from underneath, unfortunately. I think I want to use plastic tools on this radio. And it's a very, very small hole there. Yikes. Well, I'm going to have to stop and fish out some tools here. Okay, so I'm getting ready to hook up my vacuum tube voltmeter. Let me just turn this down here. Hook up my vacuum tube voltmeter to the speaker, and I thought I'd better take a peek and see what they're doing down here. And it turns out they have a ground on one side of the speaker. So this is important because when I hook up my voltmeter, I want to make sure the voltmeter ground is on this side of the speaker, not on the other side, which I don't cost. Yeah, well, that would be the second ground, because the first ground is the signal generator, and I don't dare put a second ground in a different circuit location. It's got to be in the same circuit location. So chassis is the deal. And okay, that's good. Let's look at the radio again here. Okay, I'm just going to zoom this guy up a little bit. Wait a minute, this is not the right page. This is the page I'm after here. Okay. Now, if we look at the speaker very carefully, look at the speaker terminals. One of them is insulated, the one you can't really see on the left, and the one on the right is riveted right to the frame. So the one on the right is the grounded one, and that's where I want to put my ground connection from my meter to avoid unnecessary excitement. This is the meter we're talking about here. I certainly prefer using indicating meters with a pointer to do this kind of work than digital meters. So here's the ground that I was concerned about, and we can just put it on the chassis. Put it with the other ground. I can get it on over here. Okay. So when I say the other ground, it's the same. It's the same third wire of the green wire of the electric system. My voltmeter now, I should be able to pick up the tone here. What's the static? Not sure what to make of the static there. Okay, we'll just put this on the ungrounded terminal and see if my meter doesn't go up a bit. Yeah, put this on AC, Jim. And we'll put this way down. 1.5 volts AC full scale. Does it move at all? This is why I don't like doing this. You need so much volume coming out of the... There's nothing on here at all. You need so much volume coming up out of the speaker to move the meter enough. It's uncomfortable. You see what I mean? Have this thing screaming at us to get somewhere. Now, the reason they're suggesting this in the instructions is because they know that repair guys back in the day didn't have good quality meters. They probably didn't have one of these. There's no reason why we can't actually measure the AVC voltage and use that as the guide, and we can keep the volume rate down like that. I prefer that. Let's take a look at the schematic. We'll see where we can hook up here. Somebody got a schematic? Here's one. So we start by looking at the detector. Listen to that radio. Even with the volume down, you still hear the static coming through. I don't know. Okay. Anyway, moving back to this. So we start with the diodes. This is where the RF is converted to audio and an AVC voltage is developed. So first you look and see, are they doing something different with the two of them that are in here? Sometimes they just have them shorted together in these radios. One is going up here, and the other one... What is going on in here? What is this? Oh, this is something really odd here. I've never seen this kind of arrangement. So here's the first IF. It's very typical. You have a transformer here, and you tune it. You tune each, the primary and secondary, with a capacitor. That's what I'm getting ready to do. Come over here. We see C6A is similar to this. B is similar to this too. What's all this stuff? I don't know what they're doing here. This is some form of capacitor. Look, it looks very much like how they've drawn the capacitor here. So originally this would have been a two-section capacitor. Like one body with two capacitors in it. It must be the same thing up here. Well, I don't know. It's odd. I don't know what to say about that. Have never seen anything quite like this. I'm not going to worry about it though. The question is where to hook up the voltmeter. So usually the output is coming down from here. Okay, let's go to the volume control and see how the sound gets there. Volume control. This must be the volume control here. The input end is here. And AVC is right out here. So this is where I want to connect, right at the top of the volume control. Maybe they've just drawn this in a way that makes it look bizarre, and they've used a two-part capacitor here, which has also made the diagram look bizarre or something. I don't know. But anyway, that's the easy solution. Top of the volume control. Often the AVC DC voltage doesn't make it here. Often they have a capacitor blocking it, and so sometimes you can't use this point. But this is an easy point to find in a radio. The other point, the other side of the volume control is grounded. Grounded to the B- common bus, not to the chassis. You can still figure out which is which here, I'm pretty sure. Okay, that's all we need to know. Volume control. Right, I keep forgetting. When I'm looking at my screen, I'm seeing a full screen version of what you're seeing in the little window there, and I keep forgetting the camera's still running. Not that it matters to you. Okay. So we want to hook up. So I got to tip. I got to do something about tipping this radio because I have to do one underneath anyway. Okay, I'm going to stop and figure out how to rearrange the radio here. Something else I should have looked for on the schematic right away was how is the chassis tied into this radio, normally tied into the B- bus here, and sure enough, there we are right there, and there's the symbol for the chassis connection. That should be the only one that we find in this radio right there. 220k resistor and a fairly large capacitor, which is quite typical. Any special notes here? Oh, there's something here. Note C5, C16, R9 not used on models 110. That's what I have. I have model 110 here. Connections being shown in dotted lines. So these connections out here. Yeah, see note 2. Okay, I'm not going to worry about that. Well, you know what? It must be time for a coffee because I'm kind of losing track. Oh yeah, that's right. We're checking the grounding here. So I'm not connecting the signal generator to B-. I'm connecting it here. Probably just fine for what we're doing. Voltmeter, on the other hand, voltmeter, that's not good. I think I got to move both ground connections to the B- bus. We got to find this capacitor, and it'll show us for sure where the B- bus is. Also, I looked at, just noticed this, that the volume control is tied directly to this. Yeah, so I know where this is actually already. Which side? What? Okay, coffee time it is. Okay, so looking back at the radio now, which is switched off, the volume control and its 3 terminals. The two outside ones are of interest. One of the outside ones is going to the B-, and the other one is the input where the signal's coming in. That's the one we want. So when I look at the connections, I can see a green wire, a little short wire going to the back of the volume control, the switch part, the on-off switch part. And I can also see a black wire coming from the same terminal going this way, and then it's reaching the negative end of the filter capacitors. There's no question this is the B- connection. So we're going to want to use that as the ground for test equipment and that. So I'm going to use a clip lead rather than try to put a bunch of big clip leads in there. I'm going to clip lead to the clip lead. That's what I'm going to do. Radio's not on while I'm doing this. So this should allow us to get a realistic voltage reading if I now, I now throw this over here. Okay, am I too excited? What's going on? This is nice. Stay up here on the bench. My mother was always upset because I had too many wires. She always said, "There's too many wires." Yeah, because I was always fooling around with wires. Okay, and so signal generator and voltmeter grounded to the B-. Now we want to bring out the other side of the volume control, the input side, which in this radio is carrying the AVC voltage. So I need another clip lead here, and you know, I'd be smart to check these clip leads because once in a while a clip lead fails, and that's a little tricky to realize what's going on. So I'm just going to check this real quick. No problem there. And we're going to check this one here also. Yeah, no problem. No problem. I have a little pile of dead clip leads, and then periodically I will go through the pile and fix them all up again. So we want this to get on the oh, it's a little awkward to get in there. So coming to it is this resistor. I don't remember this in the diagram. That's a 33K resistor. We can go on this side of it. Let's do that. The voltmeter I'm using is as all voltmeters do today, has a very high input impedance, so it shouldn't drag this circuit down, and the circuit is at the point we're going into is relatively low impedance. I've got the schematic right on the screen. I'm forgetting this. Let us look. Let us look at this, and where's that resistor? So I've just connected here. I don't see a resistor going this way. 3.3. Oh, that's what it is. Oh, no, I've done the wrong thing. I've connected over here. I don't want to be over here. I really want to be here. So difficulties here getting at this terminal. It's not a lot of exposure. Although this resistor has a wire sticking out here. I'm on the wrong side of it. Definitely. Good thing I looked at that. Come on, I can get the clip lead in here, can I? Yes, I can. There we go. Okay, voltmeter connected, and I think we're ready. Okay, so double checking the ground connections. We're already here. No other ground connections on here of any sort. Everything is good to go. Okay, here we go. Dim bulbs always, because I'm a chicken. And nothing's going wrong, so give it the works. And the output of the signal generator needs to be up here. I'm dragging all this. Okie dokie. Oh, that's not so good. Don't do that. Scare the daylights out of me. Okay, so I can go in a better spot. Now, better spot would be right this wire here, in fact. Hey, there's a little tiny resistor there. What's that there for? It's a little tiny resistor, and it goes to a terminal that once had a wire on it. This is probably for external antenna. That's probably what this is. This may not be a resistor, but it sure looks like a little teeny one. Okay, we're not hearing anything. There we are. Okay, checking our frequency here, because it's been a little while. Things have drifted just a wee bit. How's our meter doing? Of course, I left the meter set on AC, but this is not AC anymore. This is now negative voltage. And let me just move this here so I can do this. I'm going to vary the input frequency here, and we'll see the AVC voltage go up and down. Yeah. So this is the real tune spot here, and the frequency on the dial is 459. And where we really want it is here. We can still hear it, which is excellent, which means it's just a matter of making it stronger, which is not too hard. Now I got a couple tools here I did not practice. I should have practiced. I got three tools here, skinny ones. So these two are different than this one. These two long, slender plastic, and when if you hold the end down here, you can twist and store energy in here. Same with this one. If the screw is sticky, what will happen is I'll twist and it'll go bunk, bunk, bunk. I won't get smooth action, and so that's from the twistiness. So these aren't very good. But if the screw is nice and loose, no problem. What's that sound? This is the same kind of thing, only much stiffer. This one, it's stiff. Often I use metal tools when I do these because I need the stiffness. So we're going into capacitors, so I could potentially use a metal one, but let's start with the fat stiff guy. Will he fit? It's right under here. It's interfered with by this wire. Oh. Okay, so I'm in. You can see there's that much play in the screw. I don't know, boy. Am I really in? That doesn't feel right. Okay, watching the meter over here. So you see it went up and then it came back. That's the AVC action, pulling it back. And that's what makes aligning it with AVC tricky. You can still do it. He says, this is behaving a little weird. Okay, we're up there. Let's leave it there. Do the top one now. Wow, do you think this thing was a little out of alignment? So if you align it at the wrong frequency, radio's going to work, but it really is designed to be at a certain spot. Very interesting. We've made the IF so resonant now that it's just doing its own thing. It's possible it's because of this antenna connection is not appropriate. Let me just take it right off and see if the sound goes away. Yeah, probably need a smaller capacitor here. Smaller capacitor, please. I have one really handy here. So, need an itty bitty capacitor. Itty bitty capacitor with a clip on it. I have one. Where is it? It's not in here. It's wandered off. It's probably clipped inside somebody's radio somewhere. Here we are. I got it. Here we are. Let's try this little guy here. Maybe it'll help. Or we'll make the connection in a different fashion if this doesn't work out. So I already have this capacitor. Okay. Ooh, it's heading into the radio here. Don't head in. Okay, now when I tune this up, let's see, did it affect the whole tuning doing that? Maybe it did. Had too much of a... Too much of the signal generators. Okay, let's try. Watching the meter there. So as soon as it breaks into oscillation, it generates a strong signal in the radio and produces a strong AVC. These kinds of oscillations usually indicate a capacitor needs to be changed. He's changed them all. So there are some radios that you cannot align perfectly. You need to misalign them slightly to avoid exactly this kind of oscillation problem. Let's take this off. Does it oscillate now? No, it's from adding that piece of equipment. So the way I'm going to inject, I'm going to change the injection method here. This. I'm going to use this coil. We're going to inject it into the antenna with this guy and see if that doesn't. All we need is just some signal going in there. It can get in there anyway at all. Let's put this under here. So I don't hear it, but I got to turn up the power on the signal generator now. Okay, now we hear it. We probably aren't going to get an oscillation. So we're going to watch this meter again. I'm going to repeat this. Now we know the signal generator antenna connection is not throwing anything off anymore. There's definitely something weird about this. Okay, doing the top. And one last thing. Everything I do and everything I say, you know, take it all with a grain of salt. There can easily be stuff I don't know. Okay, that one's done. Now the other one is really awkward. Down, like it's awkward to do with the radio up like this. Now I've got clip leads going into the bottom. Okay, so I'm trying to set the alignment tool, and it's not going in. I can't see what I'm doing there. Let's see, can we rotate this? How far can we rotate it? Okay, that's much better for me. Yeah, great screw flashlight. Just trying to get it to set into the slot of the screw. Why won't it go? It just won't do it. There it is. It's in. Okay, now we're watching the meter again. And it cammed out right away. Okay, we're back in. Feel like I'm in. Yep, here we go. That's gonna help. Okay, now the other screw. We're in. Here we go. Birdies. That's called motorboating. Okay, we'll set it at max. So this is one hot radio here. She's a hot one. Okay, just doing the IF has boosted this radio, I think, but I can't be absolutely sure because you see, it could have been tuned off on one frequency and tuned well at this other frequency. And then I place the wrong frequency in it, actually the correct frequency where you really want it, but the radio won't receive this very strong. Now I make adjustments and now the radio gets strong here. And while I'm doing that, it sounds like I'm making it strong, but really I'm just moving the strength from here to here. Now there's other elements of the radio. I mean, it does all need to be aligned properly to get the max out of it. But it's easy to be fooled and think you're doing great things or having a great. I am doing great things. I may not be having the greatest effect. That's what I want to say. Okay. Next alignment is to do the RF alignment. Let's just take a look at the instructions here and see what it says. It says we go to the 1475 reference mark, generate 1475, use a 50 picofarad. That's a small capacitor. Adjust C1, D, and B. C1. How much you want to bet it's here? Yeah, it's the tuning capacitor, D and B, oscillator and RF. In this radio, when you look at the capacitor, you see that the two sections are different sizes. Small size is the oscillator. Big size is the antenna or other tuning thing going on. And are the plates bent on this? They do not look bent at all on this radio. Nobody has bent I'm looking at the outside plates. Nobody's bent them out. And not bent out in the factory. That's kind of the main thing there. Put this up. So that's a pretty healthy voltage now. 5 volts. Wow, it's good. It's good enough. What do we need to do here? We need to fix my poor signal generator. Okay. So my signal generator has a leaky capacitor in it, and the longer I run it, the higher the indicating meter goes until it gets pinned hard at the top. And so I'm trying to keep an eye on it. I'm talking about this guy here. It gets pinned up at the top, and the last thing I'd want to do is burn that out, burn that meter out. Oh. So someday I got to go inside that thing and find this capacitor, and who knows what else is in there. Okay, now we need to stop briefly while I drink some coffee and then follow these instructions through here. Okay, very good. Okay, so first thing we need to do is make sure the pointer's in the right place on the string, and it mentioned a mark to align it to. And can you see right above my finger there's a little tiny shiny spot there? That's the mark, which I couldn't see from another angle. Now there's more marks, I can't see them now from this angle. For some reason they become invisible. So let's just go and see. The pointer should stop on this mark. Ooh, what was that? Some funny stuff going on there. So we're just past the mark slightly. And could move this on the string slightly. Now I can see the other marks now. Okay. Try to move this on the string. So I have to get a grip of the string. And you might think the way you do this is I'm going to push the pointer this way. You might want to hold the string back and push against it, but in fact that's backwards. Believe it or not, you hold the string in the direction you're pushing it. When you push a bit, slack will develop, and then the thing will slide through the slack. If you do it the other way, tension develops and it grips even harder, and it becomes harder and harder to move. That's a little secret. That's a little trick. You probably know it already. So, sometimes these things are clamped so hard, people have fiddled with them, they've stuck glue on them, they may not be able to move it. Okay, so I've got a hold of the string just above where the pointer is. What did I end up doing? Let's see. Okay, so now, perfect. The center of the pointer is on the mark. We're on the mark. Okay, so that's done. That's really important. Again, you can align the radio with the pointer in the wrong place, but you won't get maximum performance out of it, because everything really is designed to be where it should be. So now I'm tuning the radio to the to another mark. This one I'm looking at the 1475 mark. So let me get my flashlight, which was flickering on and off here. Maybe now you can see. Whoop, maybe, yeah, good flashlight. Can you see the mark right there? No. There, and you can see it briefly. It's a little tricky to do this in such a way that it doesn't. Yeah, you're not going to be able to see it. Not with that. You know, I got another camera here, but I don't want to switch. It's too much trouble. Okay, you just trust me. I'm going to move the pointer to the center of this mark. Okay, so that should be receiving 1475. I am transmitting over a signal at 1475 onto this loop, but we don't hear a thing. So I do not have the modulation on at the moment. Okay. Well, let's find out. You know, it's an alignment thing. So, where is it actually tuned? Let me turn on the. I see my meter pin. I can't unpin it. I can't unpin it. So I either have to stop. That's where it should be. We can keep going. I think I can spot the. Let's turn this down again. Come on, radio. Come on, come on, everybody. You can tell I'm starting to rush, which is a bad thing. So I'm going to hunt around and find out where the radio really is receiving. Hello? Anybody? Oh my gosh, really? What's happening? What's happening here? Why? More signal strength. Now we can hear it. Now, I don't have any, there's no modulation coming from here. There it is. So instead of 1475, it's 1431. And I've got to move that up. And we do it using the oscillator adjustment. What does it say on the instructions? It says C1D and C1B. C1D is the oscillator, and that makes perfect sense. And now I'm going to run the oscillator until we... Oscillator adjustment there. I'd like to use a metal screwdriver if I can to get stiffness. Yes. Don't push on it. Hold still. Be a little easier if... Oh, that's 14... Wait a minute. That's dumb. 1475. Let's try that again. I think that's it. Oh. Yeah. Okay, so we're set to 1475 there. Now, what's next? What's next? The next is do the antenna adjustment at 1475, same place. Okay. That's the other, the big capacitor. Somebody's put marks up here. Look at this. See, there's a little penciled mark there and a penciled mark there. Anyway, you can see that. I guess you can see that. Yeah. Somebody marked them, but they're not turned where they're marked. Okay, we gotta watch this meter here for this one. Now the meter is responding to, yes, RF. So let's just... Wow. Did that ever make a difference? Holy smokes. That's way off from where the mark was. Does that give you a good feeling? Only if we play the radio now on an antenna and see what it's really receiving. Is there another step here? Check calibration, check calibration. Go to the 965 mark and the 580 mark. And what are you supposed to do if it's not right? I don't think you can do anything. Okay, so the radio is really hot, which means it's going to receive well. Next thing, let's just try picking up some stations here. So I'm gonna go back to my antenna loop. Ooh. Didn't like that. How come it totally changed sound here? Because I just pulled the loop out. That's why. So again, what I'm doing is I'm connecting an outdoor antenna with an amplifier, small amplifier, a mini whip antenna, a long lead back into here to this loop. And we'll now go see who we can pick up. So you couldn't pick up anything before, I don't think, if I remember right. Up here, up at this end. You gotta get a strong station to judge the sound quality. You can hear the sharpness that I've got it really sharp.
Of all the people, the question who is Aaron F. and Boone?
Might be too sharp.
Sharp people, yeah.
You think that would be not a healthy thing for dead animals to be around? Yeah, I would think that would.
Did he say that would not be a healthy thing for dead animals to be around? What? I guess they're talking about the situation in Florida.
Avec une nouvelle du journal de Montréal. Pour les cartes de crédit du gouvernement, on sait que le gouvernement...
Very particular sound in this radio right now. Oh, I hope I wasn't. Hope that wasn't too loud. That squeal. That squeal is telling me something about this radio.
The mother is in the balcony, and the kids are down here with the father and his gumad. If this was the 80s, the kids would have been up there, and the parents would have been down here.
Sebastian Maniscalco, Casino Rama Resort, Friday, March 28th and Saturday, March 29th. Get tickets now at Ticketmaster.
Casino Rama Resort is across the lake from me. I can look out my front window and see it on the other side of Lake Couchiching. Hear that squeal? I'm going to tell you what I think it is. Once you get it tuned, you don't hear the squeal. Radio's pretty quiet at this end of the band, but this is the business end. So I'm going to adjust that antenna adjustment down here and just see if we can't get a little more at this end of the band. You certainly can, but we might be killing the other end. So what's all that swooshy stuff? You notice the AVC voltage is sitting. We're not tuned to any station, but what's it doing way up here? Why is it, as I tune slowly, why is it slowly going down? Why now you can start to hear some of the noise, some of the atmospheric noise. The AVC is relaxed enough to let the radio receive better. Short story, I think the IF is oscillating. It's oscillating at exactly 455. If you tune the radio so that the incoming antenna signals converted to exactly 455, then the two frequencies match. There's no difference frequency, or if there is, it's so low you can't notice it. But if you tune the radio slightly off, then the received signal won't be at 455 anymore. It'll be at like 456, let's say, just a little off. There's a difference frequency there of about 1,000 hertz, and that's what you're hearing as I tune through. Right? Or I can't whistle. So I have to do the swooshy sound. I can't whistle that way. But it would be like a woo, woo. Right? You're getting the difference frequency as you're moving in and out. I think the radio's oscillating in the IF, and I think it's because I peaked it right up. It also has this characteristic sound of a regenerative radio. And what you're doing is you have something that's ready to oscillate, and as you bring in a frequency which matches its ready to oscillate frequency, it starts helping out, and you get kind of a weird extra, I don't know, canny sound. I don't know how to describe it. So that's the story there. I also notice when we tune things in, absolutely there's not a lot of trouble. A lousy speaker maybe, but not a lot of trouble. I would think there'd be more trouble. That again indicates tight IF with a big Q on it and propensity to oscillate. There are capacitors in the radio to try to prevent this oscillation. The oscillation requires a feedback of the signal from the output back to the input, and there are capacitors that are trying to trap that, but it could be too much. You could just peak the radio up so much that there's just too much trying to get back to be quelled and avoid the oscillation. It's not freely oscillating, but it is. I don't know what to say about that. Is it freely oscillating? Well, I guess it would have to be if you've got a high AVC when there's no tuned signal. How can this possibly happen? Because there's an oscillation inside the radio itself. Further proof of this would be putting the SDR on it. So I think I'm going to stop at this point, and then tomorrow we're going to experiment a little further and look into this whole question. The decision I have in front of me is leave it the way it is, or detune the IF a little bit to bring things down so there isn't so much likelihood to be an oscillation. Find a capacitor not doing its job, or something went wrong. The last guy worked on it. He made a mistake. It's not very likely. Not very likely at all. There should be a big... Let's look at... The last thing we'll do, we'll look at the schematic and try to identify parts that are responsible for helping out with this circumstance. Now, I'm going to save that for tomorrow. We'll do that tomorrow. I'll make the whole thing a package tomorrow. I'm done for today. So, thanks a lot for watching, and I hope you're finding this interesting. Not doing much of this radio other than tuning it around a bit. Okay, we'll see ya.